So last week we started graphing equations, and we had the steps on how to graph equations. Step one was to write it in function form. What does that mean, function form?
Find x.
Leave y by itself. Solve for y, get y by itself, isolate y. Remember, form is just the way it looks, the way it's organized. And if you take an equation and you organize it to the point that you get y by itself, that's what we call function form, solving for y. Then after you get the y by itself, then you worry about making an xy table and plugging in three easy numbers. Most of the time 0, 1, and 2, but not all of the time. If you end up with a fraction in front of your x, you want to use that denominator, because if you use 0, 1, and 2, 0 always works, but if you use 1, it might give you a fraction, and we don't like graphing with fractions. And then you graph the coordinates and draw your line and put some arrows on it. Anyhow, right here they ask us to find three solutions. We might as well practice getting it in function form. As you can see right here, it says 3y equals x minus 6. If I wanted to get it in function form, what would I have to do? Divide by 3. Divide everything by 3. Let me ask you this also. What value's in front of x?
1.
1. So there's an invisible 1 right there in front of x. So when you divide by 3, now you're going to have it in function form. Let me rewrite my function form equation right here. So when you divide everything by 3, you end up with y equals 1/3. 1 divided by 3, you leave it 1 divided by 3 as a fraction. X minus 6 divided by 3, that is 2. So there's our function form equation. Y equals 1/3 x minus 2. Now we're ready to make an xy table, an input-output table. Plug in three easy numbers, get out three easy answers. 0 always works. So if I take 0, which is my x value, and plug it in for x, I'll end up with 1/3 times 0, which is 0. And then 0 minus 2 is what? -2. That's right, -2. Thank you. So your input 0 give you your output -2. You guys didn't really respond to that. Does anybody, do you guys understand what's happening? Look, you rewrite the function and you plug in the 0 for x, right? So when x is 0, plug in 0 for x. X is your input, 0 you're plugging in. So it's really going to say 1/3 times 0 minus 2. What's 1/3 times 0?
0.
That's just a big giant 0, it's nothing. And then what is 0 take away 2? -2, that's how we get this output. So for the input 0, we got the output -2. And ladies and gentlemen, that is a coordinate. And we could graph that coordinate. Let's graph it. 0 on the x, -2 on the y. Let's put a dot right there. So of course, we need more points, right? Now, most of the time we use 0, 1, and 2. But in this case, we're not going to use 0, 1, and 2. We could if we wanted to, but we're going to end up with fractions, because if I take a 1 and plug it in right there, it's going to say 1/3 times 1 is 1/3, and then 1/3 minus 2. That answer becomes -1 and 1/3. No, -1 and 2/3. And that's not fun to graph. So instead of plugging in 1, remember, you don't have to use 0, 1, and 2. You could plug in any numbers you want. So the better number to plug in right here in place of x is the denominator itself. So instead of 1, let's not use 1. What am I going to use?
2.
3. Now, why 3? Because the denominator is 3. So when we plug in a 3, it's going to work out nice. So when I plug in a 3, let me show my work here. I have 1/3 times 3 minus 2. So when I go 1/3 times 3, the 3 and the 3 cancel out. What do I have left? I have a 1 take away 2. And 1 take away 2 is -1. You got that, Ricky? So for my input 3, I get out a -1. And that's another solution. That's another coordinate. We could go to the coordinate 3, -1, and put a dot right there. I could draw my line right through it, put some arrows. But let's say I wanted this line to be longer. I could plug in more inputs, right? What would another nice input to plug in be?
2.
Would it be nice to plug in 2 right here? You'd get a 1/3 times 2. You end up with 2/3. You get a fraction, right? That's not that nice. 6 would be great. 6 would be great. Now let's actually show our work here. 1/3 times 6. So I wrote it right here. 1/3 times 6. What happens with the 6 over 3? It divides, right? What's 6 divided by 3? 2. So you really end up with a 2 right here. Let me put a 2 right here. Even with the 1 times 2 is still 2. So you have 2 take away 2. What's 2 take away 2? That's 0. So for my input 6, I get an output of 0, right? Now, did I have to plug in 6 to be able to get that next coordinate? No, I could have used the pattern from one point to the other. I go up 1 over 1, 2, 3. So if I wanted to extend it further, I could go up 1 again and over 1, 2, 3, and I'll be off the graph. But that's okay. Draw your line right through it. That's a coordinate 6, 0. Or likewise, you could go backwards. Instead of going up 1 over 3, you could go over 3 down 1, or down 1 over 3, and continue going down 1 over 1, 2, 3, and put a dot right there. And that would give you another coordinate and extend it longer if you wanted to. So what is this new coordinate that I got by using the pattern? This coordinate right here. -3, -3. Now, what does that mean? If I were to plug in a -3 into my x, I would get out a -3 for my y. Okay? So, all of this is a review from last week. We need to know, well, let's go back to the questions. Find 3 solutions. How many did we find here? We actually found 4, the -3, -3 with the pattern. But, yeah, if they say find 3 solutions, here are 3 solutions right here. 0, -2, 3, -1, 6, 0. How many solutions exist? Infinite. They go forever and ever and ever. Okay. Question number 2, graph it. We already did. Question number 3, what inputs did you use? What inputs did we use? 0, 3, and 6. Perfect. What outputs did we get? -2, -1, 0. All right. So this all links into today's lesson.